Hello, for this lecture video, I'll be talking about physical properties of solutions, more specifically, concentration units. The following shall be the learning objectives. Differentiate types of solutions based on amount of solute and solvent. Number 2, quantify. Okay, so quantify concentrated solutions through mole fraction, molarity, and molality. Thirdly, solve stoichiometric problems involving concentration units. Let me start by providing definitions and descriptions of the three types of solutions based on the amount of solute. Saturated solution. A saturated solution contains the maximum amount of a solute that will dissolve in a given solvent at a specific temperature. Take note of the word that is highlighted with an underline, that is that a saturated solution must contain a maximum amount of solute that will dissolve. Say, for example, a certain solvent has a maximum amount to dissolve for a solute being 5 grams. So that is the maximum. Now, a solution will be saturated if and only if the amount of solute is also 5 grams, thus attaining the maximum. Kumbaga, masasabi po nating saturated ng isang solusyon kung naabot po ang maximum na bilang na kayang i-dissolve ng isang solvent. Kung ang isang solvent ay kaya mag-dissolve ng 5 grams of substance na solute at ang nilagay natin ay 5 grams din na solute sa isang solvent na ito, yun po ay masasabi nating saturated kasi naabot niya po yung maximum na bilang na kayang ma-dissolve. Now, what about an unsaturated solution? Unsaturated solution contains less solute than that of the solvent or has the capacity to dissolve. Now, take note of the phrases less solute than the solvent has the capacity to dissolve. So, malalaman po natin na unsaturated ang isang solusyon kung hindi nakuha o hindi naabot ang maximum na bilang ng solute na kayang i-dissolve ng isang solvent. Ayan po ang salitang o mga salitang less solute than the solvent has the capacity to dissolve. Halimbawa, balikan natin ang isang solvent ay kayang makapag-dissolve ng 5 grams. At nilagyan natin ng solvent na ito ng 2 grams. Kung ang maximum ay 5 grams at naglagay tayo ng 2 grams, hindi naabot ang kapasidad. Less solute than the solvent has the capacity to dissolve. Therefore, unsaturated. The next one or the next type would be supersaturated solution. A supersaturated solution contains more solute than is present in a saturated solution at a specific temperature. To make things much simpler, as the underlined phrases would suggest, a solution is termed to be supersaturated if and only if it starts as a saturated. Bago po maging supersaturated, syempre napakasimple, dapat saturated muna siya. So a supersaturated solution, the number of solute is more than the solute present in a saturated solution. Halimbawa, ang saturated solution ay ang maximum na ang solvent na ito sa isang solution ay kaya niya mag-dissolve ng 5 grams. Tapos nilagyan natin ng 7 grams of solute. Dahil 5 grams lang naman ang kanyang kaya, nilagyan mo ng 7 more solute than is present in a saturated solution, super saturated. More solute than is present. 5 grams of solute ang maximum ng halimbawa natin na solvent, na solution. Binigyan natin ng 7. Sobra. Super saturated. Okay? Now, to make things much more realized or be understood, let me give an example via this particular illustration. Okay? So say for example, we have here a cup. Or one afternoon, maybe you decided to make a cup of tea. Okay, so it's an afternoon tea time. Now, this particular cup contains water. Now, say for example, okay, let's say a cup of water can dissolve 5 sugar cubes. Okay, so halimbawa, ang isang baso ng tubig o isang cup o tasa na iyong paglalagyan ng iyong tsaa ay kaya mag-dissolve ng 5 sugar cubes or let me write it as 5 SC. Okay? 5 sugar cubes ang kaya niyang i-dissolve. So say for example, we shall have here cup number 1. Okay, so let us have here cup number 1. So cup number 1 or case number 1. Now say for example, I added 2 sugar cubes. Now, if I added 2 sugar cubes sa cup of water na ito, ang kaya niya ngang i-dissolve ay 5. Yung 2 sugar cube madi-dissolve, pero ang ating tsaa o solution ay tinatawag nating unsaturated solution. Ulitin ko po. Ang cup of water na ito ay kaya mag-dissolve ng 5 sugar cube. Yung cup number 1 na pine-prepare natin, nilagyan lang natin ng 2 sugar cube. Na-dissolve ang 2 sugar cube, ngunit dahil hindi natin na-attain ang maximum o mas mababa sa maximum na kayang i-dissolve, unsaturated lang. Okay? Now what about cup number 2? So this time, I'll be preparing cup number 2 and I added 7 sugar cubes. Ayun. Dahil 5 nga lang ang kapasidad o maximum, 5 out of 7 sugar cube shall dissolve, while the remaining 2 sugar cube shall settle at the bottom of the cup. Ulitin ko po. 7 ang nilagay natin. 7 sugar cube. Nalagpasan natin yung maximum na 5. Yung 5, madi-dissolve. Sige, kasi nga 5 yung maximum. Ngunit, yung 2 na hindi na-dissolve ay mag-settle sa ilalim ng ating cup. Settle at the bottom of the cup. Ang tawag po dito ay saturated solution. Dahil na-attain natin yung maximum na 5. Pero may 2 tayong sugar cube na hindi na-dissolve. Nag-settle lang sa bottom ng cup. Saturated. Ngayon, ituloy natin ang kwento o pagpe-prepare. Cup 2.1. Gamit ang tasa na ito, parehas sa tasa, ituloy natin itong cup number 2. Itawag natin siyang cup 2.1. Now, say for example, the same cup, the same glass from number 2 was heated. Ininit natin yung baso na naglalaman ng 7 sugar cube. Dahil ininit o tinaasan ng temperatura, yung 2 sugar cube ay na-dissolve. Ulitin po natin. Gamit itong parehas na cup na ito, cup number 2, gusto natin matunaw itong 2 na sugar cube na nakasettle sa ilalim. Ang ginawa, we added heat. Because of the addition of heat, the 2 sugar cube dissolve. Okay? Now at this point, because of the addition of heat, the 2 sugar cube dissolves. Kahit na alam natin, di ba, 5 ang na-dissolve. Tapos ininit natin ng cup, na-dissolve na din ng 2. Total 7. Kahit na alam natin na 5 lang ang kapasidad, pero 7 ang nag-dissolve. Ang tawag na natin ngayon ay super saturated solution. Nalagpasan natin yung kapasidad. Ang kapasidad 5 lang. Sige, out of 7, 5 nag-dissolve naturally. Pero yung 2 na nakasettle sa ilalim ng cup, na-dissolve natin sa pamagitan ng pag-init itong mismong tasa. We heated the solution. 7. Even though we know that only 5 can be dissolved as a maximum dissolution. Okay? Now, after quite some time, itong tasa na to, itong cup number 2.1, di ba na-dissolve itong 2 sugar cube? Hinayaan na lang natin. Hinayaan natin at hindi natin inanom. After a while, itong 2 sugar cube ay bumalik. Bumalik sa pamamagitan ng precipitate. Ulitin natin. Cup 2.1. After quite some time, sige, na-dissolve na yung 7. Mainit pa yung tasa. After quite some time, lumamig. Lumamig na ang temperatura, bumalik na sa normal na temperature, hindi na mainit yung tasa. Kapag bumalik na sa normal na temperatura, yung dalawang sugar cube na na-dissolve kanina dahil sa init, ay babalik. Magiging precipitate. Okay? And now, the two sugar cubes shall return as a precipitate when the temperature settles down. Okay? Ito pong precipitate na ito na tinatawag natin sa pang-araw-araw na aktibidad natin. For example, ikay naghahanda ng iinumin mong Milo at napadami yung nilagay mong powder ng Milo. So sobrang dami nilagay mo. Tapos gumamit ka na mainit na tubig para matunaw. So hinalo mo, halo-halo. So madami nilagay mo, pero lahat na-dissolve naman. Pero after quite some time, nakalimutan mo na inumin. Lumamig na. Nung lumamig na o bumalik na sa normal na temperatura, after mo inumin o ubusin yung laman, napansin mo parang may graba-graba o parang buo-buo sa ilalim. Yun po yung precipitate. Meron din po na ganito nangyayari sa mga iniinom nating kape na parang may buo-buo sa ilalim, parang graba-graba o parang mabuhangin. Yun po yung precipitate na galing sa supersaturated solution. Dahil sobra-sobra yung nalagay mo, sobra-sobra yung na-dissolve. Dahil nga mainit yung tubig, madidissolve lahat talaga because of heat. Pero after na bumalik sa normal temperature at lalamig, after quite some time, makita mo yung mga sobra na hindi na naturally na-dissolve ay babalik as precipitate. Okay? So that is your unsaturated, saturated, and supersaturated solution. Okay, so hopefully this particular part of the lecture is clear. Now at this point, we shall continue by having the concentration units and its equations. Now these are the following concentration units based on moles: mole fraction, molarity, and molality. Let us start with mole fraction. Now, mole fraction is characterized by the equation mole fraction of A is equal to moles of component A all over the summation of sum of all moles, or rather, the sum of all moles of the components. Again, mole fraction of substance A, or may that be whatever substance you are focused, is equal to the focus substance all over the summation of all mole values of the components. Let me give an example. Sample problem number 1. A solution is prepared by mixing 25 grams of water and 25 grams of ethanol. Determine the mole fractions of each substance in the solution. Okay, so let me show a brief explanation for this problem. Now, as you can see, the solution was made out of water and ethanol. Now, at this point, we actually have two components, A and B, water and ethanol. Dahil ang sinabi ng tanong, hanapin ang lahat ng mole fraction. Kung gaano kadami yung substance, ganun din kadami o ilang beses kang magsasolve ng mole fraction. Dahil may dalawa, at sinabi isolve parehas, dalawang beses akong magsasolve ng mole fraction. So say for example, you need to solve for 3, for 5, for 7 substances, and you were asked to solve for each mole fraction, you need to solve 7 times, 5 times, 3 times, whatsoever. Now in this context, I have 2, and I need to solve for each. That is why I need to solve 2 times. So given, so we have here 25.0 grams of water, and then 25.0 grams of ethanol. Our requirement would be mole fraction of water and then mole fraction of ethanol. Okay, and then our equation is mole fraction of any substance is equal to n sub A all over n sub A plus n sub B, or in this case, yung ikalawang isosolve natin, mole fraction of the second substance is equal to n substance B all over the summation of the two mole value. Okay? Now, before you proceed with the solution, make sure that all quantities have appropriate unit. Ang kinakailangan ay mole unit. Dahil naka-gram pa ang mga given, kailangan natin sila i-convert. So gram into unit mole via molar mass of each substance. So kailangan pa po natin i-convert bawat isa. So let us convert 25.0 grams of water into unit mole via molar mass. So since there are no molar masses of water provided, I need to solve for the molar mass of water from scratch. So 2 atoms of hydrogen and then 1 atom of oxygen multiplied by their respective atomic masses. So for hydrogen, it's 1.01 according to the periodic table. And then for oxygen, it's 16.00. Input this in the calculator, 18.02 gram per mole. So now that I have the molar mass for water, I may now convert 25.0 grams water all over 1 mole, 18.02 grams. Lagi pong tandaan na kailangan natin makancel ng gram, kaya ang unit na gram ay nasa denominator at laging nakapartner ang molar mass na value sa gram. Habang ang mole ay nasa taas dahil yan ang required at nakapartner naman siya sa number 1. Input this in the calculator. This would be 25.0, 1 all over 18.02. Round it off according to 3 significant figure according to the given 1.39. Now, my unit for water is now okay. Naka-unit mole na. Next is ethanol. Since naka-gram pa ito, kailangan natin siya i-convert into unit mole. So same process, just like what we've done or I have done here in water. Okay, so molar mass of ethanol, C2H5OH, C2H5OH, 2 carbon, 6 hydrogen, 1 oxygen. Multiply them by the respective atomic masses found in the periodic table. Okay, and then input this in the calculator. This will be 1 times 16.00, 6 times 1.01, 2 times 12.01, 46.08. Okay, so I can now convert 25.0 grams of ethanol into unit mole. Grams is cancelled. I shall have unit mole for ethanol. Input this in the calculator. 25.0 times 1 all over 46.08. Round off according to 3 sig fig, according to 25.0, 0.543. I now have appropriate unit. Okay? Again, itinatama pa lang po natin ang unit from being gram to mole. Kasi nga ang kailangan na equation ay unit mole. Okay? Nagko-convert pa lang. We may now proceed with the main solution. Mole fraction for water. So 1.39 moles of water. Okay? All over 1.39 moles of water plus 0.543 moles of ethanol. Okay? Summation ng ating denominator. Okay, dahil summation po yan. 1.39 plus 0.543. 1.933. 1.933 mole. Mole will be cancelled. Ang mole fraction po ay walang unit. Okay, so ang ginawa ko lang po ay dahil mole fraction ni water, ang nasa numerator yung mole unit niya. And then sa denominator, i-add lang natin yung dalawang mole value. 1.39 all over 1.93. So the answer is this one, 3 sig 0.719. Okay, wala pong unit ang mole fraction. Kapag mole fraction, walang unit. Makakancel yung unit po. And then last one, for ethanol. So dahil ethanol naman itong kinukompute natin, ang nasa numerator ay 0.543 moles all over yung summation. Ito yung summation. 1.933 mole. Summation po yan ng 1.39 moles water at 0.543. So mole will be cancelled. No unit for mole fraction. 0.543, 1.933, 0.281. We have the following answer. Okay. Again, first step, write the given required equation. Dahil may dalawa akong substance at ang sinabi, isolve lahat ng mole fraction. 2 beses ako nag-solve. And then recall the equation. Now since ang given ay grams at ang kailangan ay mole unit, that is why I converted it first, gram to unit mole. After which, now that I have unit moles, I proceed with the main solution, having the answers 0.719 and 0.281. I have the same given required equation. Number of moles of each component, just like I've done, I converted grams into unit mole first. And then I have the same answer and same solution, mole fraction for water, mole fraction for ethanol, 0.719 and 0.281 for water and ethanol's mole fraction respectively. Okay, so let me now proceed with molarity. Now, molarity is very simple. Molarity is defined as the number of moles of solute in 1 liter of solution. Molarity is characterized by molarity is equal to mole of solute all over liter of solution. Take note of the equation. Molarity is equal to mole of solute all over liter solution. Mole solute over liter solution. Let me give an example. What is the molarity of a solution prepared by dissolving 25 grams of sodium hydroxide in 325 milliliter solution? So given 25.0 grams sodium hydroxide, automatically this is solute, and then 325 milliliter of solution. Our requirement is molarity. And then our equation is molarity. Know that molarity is capital M is equal to mole of solute all over liter solution. Okay. Now before I proceed with the computation, make sure that all given quantities are appropriate. Mole solute. Our solute is in unit grams. So that is why I need to convert gram unit into mole solute. Again, kinakailangan mole solute. So hindi ka muna pwede mag-compute. Kailangan gawin mo muna ng mole unit itong grams na binigay. So this is via molar mass. Now since there is no molar mass provided for sodium hydroxide, I'll be computing it from scratch. 1 atom each according to the formula, and then multiply them by their atomic mass. You can find the atomic masses of each element on your periodic table. For sodium, it's 22.99 as I've written. Oxygen 16.00, hydrogen 1.01. Input this in the calculator. E.00. Okay, so I may now convert 25.0 grams of sodium hydroxide multiplied by 1 mole all over 40.00 grams. I now have unit mole. 25.0 times 1 all over 40.00, 0.625. I now have appropriate unit for my solute. Next is my solution. What we require is liter, but what I am provided is milliliter. So convert 325 milliliters to liters. Milliliter is cancelled. This shall be 0.325. Okay, so now my solute and solution are now okay. I may now proceed with my main solution. Mole of solute, 0.625 moles. All over liter solution, 0.325 liters. 0.5, 0.325. 3 sig fig, 1.92. The unit shall be 1.2 molar or mole per liter. The unit for molarity is molar. Molar or capital M. 1.92 molar or mole per liter. 1.92 molarity. Okay? With that of the problem, given mass and then volume of solution converted into liter, required is molarity, equation, mole of solute all over liter solution. Now, denominator is already liter. However, your solute is not yet in mole unit. That is why the solute was converted into mole, 0.625, just like what I've done using molar mass. By liter solution, 0.325. 1.92 molar or 1.92 mole per liter. That's one. Let me now provide or give an example and define molality. Molality is defined as the number of moles of solute dissolved in 1 kilogram of salt. Molality is characterized by lowercase m is equal to mole solute all over kilogram salt. Now this time, take note that molality is small m is equal to mole solute all over kilogram solvent. Notice the difference between molality and molarity. For molality, mole solute all over kilogram solvent. For molarity, mole solute all over liter solution. The only difference between the two is their denominator. Okay? The unit for molality is small letter m or molal. The unit for molarity is capital M or molar. Okay? Small m, molality, molal. Capital M, molarity, molar. Okay? Let me give an example. How many grams of sodium chloride must be added to 500 grams of water to produce a 1.25 molal solution? Now in this problem, it seems like grams of solute is missing. And then we already have here the kilograms, the gram of solvent, and the molality. Given is 1.25 molal. and then 500 point grams of water. So this will be your solvent. Required is solute, NaCl. And then the final answer should be in grams. It's very specific according to the problem. Equation, molality is equal to mole of solute all over kilogram of solvent. Now, let us check if the following are given. Your molality is already provided, so check. However, your solvent is not yet okay because the problem requires that the solvent should be in kilogram. So convert 500 gram into kilogram. As a gram. Gram will be cancelled. We shall have 0.500 kilogram. So now my solvent is now okay. Okay. And I need to compute for solute. So we need to compute for our, we need to compute for the numerator, solute. But even though the equation gives us mole solute, the requirement is solute grams. So we need to derive it later on. So first, derive an equation for mole of solute. So derive an equation for the numerator. That is very simple. What we need to do is multiply both sides by kilogram solvent. So now we have an equation for the requirement. Mole solute is equal to kilogram solvent multiplied by molality. Okay, now that kilogram solvent is okay and molality given is already okay, we may now proceed. Okay, so the solution shall be multiplying this to 1.25. So 1.25 molal multiplied by kilogram solvent, 0.500 kilogram. Okay. So this particular unit, molal, can be interchanged into mole per kilogram. So that is why kilogram can be cancelled and the remaining unit now is mole. Okay, so mole of solute. So input this in the calculator. 1.25 times 0.500, 0.625. Okay, 0.625 mole of NaCl. Now, since the problem requires us grams, I need to convert unit mole into gram. So mole into unit gram via molar mass. Now, since there is no provided molar mass for sodium chloride, I need to compute for that one from scratch. So one atom each, multiply by their atomic masses, so 22.99 and 35.45. Just to check, sodium, 22.99. Chlorine, 35.45. Okay. So input them in the calculator. 8.44. So convert 0.625 moles. It's multiplied by 58.44 grams all over 1 mole. Mole is cancelled. I shall have now the unit gram, which is the one we are required to solve for. 0.625 times 58.44 all over 1. I have this particular answer, rounded off according to 3 sig fig, 36.5 grams of sodium chloride. And this is how we solve for this particular problem. Okay. From the PowerPoint, given, now since we need kilogram of solvent, 500 point gram is converted into 0.500 kilogram, and then molality is provided. Requirement is solute, but in unit grams. The equation is molality is equal to moles of solute all over kilogram of solvent. Now, since we need to solve for solute, derive an equation for the numerator. We shall have solute in moles is equal to molality times kilogram solvent as we derived earlier. So we now have an equation for the requirement solute. Okay, solution. Again, 1.25 molal is interchangeable with mole over kilogram. The unit molal is mole per kilogram. Kilogram shall be cancelled. We have 0.625 mole. Now, since we need grams, not mole, so we need to convert 0.625 into unit gram. Convert mole to gram via molar mass of sodium chloride. We have 58.44. The final answer is 36.5 grams sodium chloride. Sorry about this. This is 36.5. It is significant figure, and this is typographical error. This should be sodium chloride, Na, capital N, small lowercase a, capital C, and lowercase l. Okay, 36.5 grams of sodium chloride. Okay, so that is how we solve for molality. Okay, so let me just reshare my screen. All right, sorry about that. Okay, so the following are the summary of the formulas. You have here mole fraction, molarity, being moles of solute all over liters of solution, and then molality, being moles of solute all over kilogram of solvent. So these are your formulas for mole fraction, molarity, and then molality. All right. So I hope you learned a thing or two about this particular lecture. And I hope and I also pray that the examples and the concepts were clear. Thank you and have a great day.